is about natural language processing. Researching on natural language processing, but it was only NLP earlier. NLP plus deep learning. It is NLP, natural language processing. What was it? That is what I'm going to start with. So first, we had some files, we had some documents, we had some data where there were numbers, there were facts written as sentences, measurements that the train is going at 160 kilometer or the car is going at this many. We had a way in which we were interpreting the data into numerals. All of the process the natural language in itself in which a man speaks. I speak, or I write, or I hear, what is all natural. But we always have the way of converting this natural language for a long time because we did not know how to deal with the actual text that we have. Like what my forefather language is not present anymore. There is a different terminology coming in each year, each month. There is something that keeps changing. So text is not static. In the way we speak today, tomorrow, manner and different way altogether, basis of the language. So evade from using text as is. But I want to tell now on I'll go about there. So like I mentioned earlier, data is going, but it's up to me on how I'm going to organize the data and tell a story out of it. How I'm going to put and how I'm going to come up with a story and tell like, okay, this is what the data is telling me. There's a number 5, there's a number 10, and these are or they are actually proportional to each other, inversely proportional to each other. They are actually affecting each other. So it is up to the person, an organized manner, make the unstructured data, unorganized data into a structured, organized data. And so that's the most difficult thing that when we look into text. It is a little easier in numerical analytics because we already have it in some columns. If I go to I comma j, which represents the row and the column, this particular cell gives me this information. It is little structured for me. Now there are cases where it is categorical or the data more normalized in even in numerical analytics, but basis like what I'm talking right now, the first sentence and the second sentence, if you just keep counting the different number of unique words that I'm are going to deal with this. That was the massive challenge that we had. So how do we convert the data? I have the words, someone is speaking, I've recorded it. Derive something out of this was the biggest challenge when we go into natural language processing. Tell the story out of it. So data is the oil booming this much because we had lots of challenges which we could not modeling with traditional traditional ways of doing the programs, right? It is we were not able to progress much. But then once artificial intelligence came in, and then when we engulfed NLP into artificial, I think today, whole day, I think everybody would have taken you through the applications of artificial intelligence. So I will not repeat terms of the applications, but it finds its way into each of the industries, right? AI finds its way through each of the industries. I have just put out a topping, obviously. I give a lot of feedback. In healthcare, we take the diagnosis and we come up with some analysis, we come up with a summary. In agriculture, on even when our homes would become a little smarter, having a face recognition. Politics and government, we know the impact it has created in the recent politics these years. And similarly, I am from a banking sector. I work in an industry. I work in a bank. So how do we transform the things in the bank? That education, I did not tell you on how this online education is booming and how this has become, and how we're going to use AI over there to help our students get a better outcome, right? So AI is there everywhere. Now I would like to go into more of natural language processing, right? So, like I said earlier, LP plus ML, and then LP plus AI is ML has certain constrictions, right? Based on the observations, it is not going to work beyond a point if it has not had a similar data that it has observed in each other. We always consider AI is a little, and for that reason, now people have started asking like, can you do it in deep learning? We don't want the traditional machine learning. Can now something like a maximum, right? These are all going to be our basis of machine. But when we move one step ahead, right, which is going to be the artificial intelligence of the information, that's how learnings. The more the layers, the deeper the network, the better the outcome is in ML. So this is just depiction of how it evolved. Initially, we were typing and it across, sending it across. Still, there were delays. Then people were having a way to.
Madam, we lost your audio, madam. Second minute.
No, ma'am, you are not audible. No, ma'am. We are not getting you.
Madam, are you using any Bluetooth? Using words, madam.
Just share my screen again. Yeah, I was audible till here.
Yes, madam. You are
Yes,
audible,
madam.
please.
So I will just start with how we knew earlier we were just sending letters and typing it. First it was handwritten, then we were typing it, then we had a through text once the internet evolved, and then now we are in a phase that we don't just text, but like how I'm doing right now, we are communicating the world, right? So that's how it has evolved. And now when this evolution began, we also are thinking that when I to automatically transcript it for me at a later point. That's what I'm looking at. And a later point, right? And from that audio, can I also type in so that I don't have a mic probably, let's say, then to speak due to the situation or due to my physical abilities, right? Then I is there a possibility that I can make this solving, and that's how the path to NLP is going into. So in those angles, if you see those perspectives, major notable NLP applications that we have been successful in developing, some machine analysis, like what I'm saying, is it something that's going to be affecting the mood of the other, anybody understands this text classification, chatbots, which is going to be a little more complex. It's like it's going to have intent or text classification, it's going to have the speech recognition also, it's also going to have a textual chatbot or a audio based chatbot, and then we also have summarization. Now we are in such a fast pace of 60-page paper or a 60-page article. So is there a way that I can summarize the entire information using either abstract to what is the paper about, right? And obviously spelling correction, we already have it in all mobile, but actually for the model that is there in the context, being into another one into the actual learning, it actually reduces my search space, a proper spelling each time rather than using different spelling for the same thing just because I was not particular about. So these are some of the notable applications that is actually leading us to a place where we want the entire transient and seamless, right? So I've already spoken on how NLP works, a 5-step process on how NLP works. So NLP understands what we speak, understands what we write it in its own step, and then it tries to do the processing, right? It tries to do the okay, what does this word mean, what does this character mean, and all of these things. But in this era, and then it tries to do the tasks such as like it converts it into from text. So this is how general NLP systems work. So like I said, there are different sound. of a person and I'm talking to the person. But and let's assume he knows English. I'm talking in Telugu, he knows Telugu. I'm talking in Tamil, he knows Tamil. So that's the only commonality that we have. Something like that, right? And with respect to that alone, the person is responding to me. So the first is actually the phones, the phonological way. The second level is the morphological way. Here, I'm just going to write. I'm not. And there are going to be some impacts made by the session. So, in common is paper 2 knows how to read the language that I have written it in. So, that is the characters of the language, the morpheme, the prefix, the suffix, the different formations of a word, which we call the inflectional and taught to the person as he grows or he or she understands the language well. So, that is the morphological aspects of a talking now for this session, and I'm trying to use the grammar forms, the lexical rules to this language. It tells me how I have to use a word, how I have the language. Then the next level is going to be the syntactic aspect where I know that the grammar word is what? Is it a noun? Is it a verb? And so on. Next comes the semantic information.
No, you are not audible. No, ma'am. You are not audible.
Information. Understand what the sentence says, what it actually tells. So, right now, let it be industrial researchers or let it be academic researchers, in general, researchers have been able, which is going to be more comprehension and more understanding in terms of what entire paragraph is saying, what is the intent of of the paragraph, what is the entire document saying, as we are trying to reach level, which is the pragmatic and the discourse level for us, and we are still working level, which is the syntactic and the semantic level. So can you just go to the next slide? Yeah. Indian languages, I definitely would like to touch a point here that there is a lot of research that has gone on for English and for French, and let's that language research. And here, when you see languages, TK, Spacey, and whatever Haggers, the Chunkers, and all of them are available for other languages, but is not present inadequate, and it is not present this more on the research in Indian languages. Indian languages this is what I would call. Can we go to the next slide, please? In terms of voice and speech and written text, what is required? So I will just skip it. So when we academic and industrial perspective, I'm a person who has been in both the what is the difference here? Do it the right way. No matter how much of our time we want to perfect it and then go about it. We have the freedom to do a lot of collaboration. All our colleges have been like, yes, do collaborate. It brings in different aspects. To industries, there is very less collaboration. So the life cycle of the work, replicate it into ML modules and then go about from there, right? So that is the difference. So can we move to the next slide? Entire life cycle that we do in terms of an ML module, and it, tag it, users, not just with respect to us as well. I think in the and a very essential point over here, quality of the tags. And then we do an exploratory data analysis to understand what the data tells any. Next, then we do the identification of what are the features that are going to. Well, we do the hyperparameter tuning on it, build the pipeline and academic researchers. We stop with 11th step in academics most of the times. And then after the 11th step, 11, 10 and 11, and then publish our results, and then comes the review. But when it comes to it may be usable by at least a few, like testing environment, it should be usable with view their feedback and then incorporate and give it as a release. And we keep monitoring the model continuously, which probably we do not do it industry because we do starts from step number 12 to 15 is what I would say in a gist. So can we go to the next slide? Yeah, thank you. So task available. Now I can represent alphabets. Let's say I alphabets in it. I can use one, then I can try to represent it. That's what we call boundary for words. I cannot say there are 500 words in a language or 5,000 words in a language. Nobody knows the upper bound to it. Functional factors that we have in a language, nobody can tell on even roughly pre-process. The way we normalize the words is what brings in the difference between NLP and other ML. More detail on embeddings because that is the major aspect for the text into some specific format in a well documented. So can we go to the next slide, sir? Yeah. So that is what are and then they go out with bag of words approach or or the n-gram or the skip-gram approaches. But these are just the basics, and we need to know on why and how we need to go about these things. So I'll just in a little detail in the next slide. Yeah. That's what I mentioned presentation. And then we can move about with syllables, which is a collection of characters. It's a subword level. Sentence and the document level. This is how we go about the embeddings. Put in these embeddings as a part of the solutions or in terms of the decision tree or the random forest. Generative and descriptive and the condition probability. But before all of this, right, we actually told us loud and clear that BERT GPT that has come telling us that the embeddings are the core factors of the model. In the next slide. So the next slide. Be aware of word to vector and glove. This approach to represent the words in the sentence or in a document. When a vector representation of the words that occur along it gives a positional representation, right? And the next is the glove. Here, how vectors, we look into the co-occurrence as well. So it also gives me the probability word relationship going on in here. And that is the difference between glove and word to came after word to vec and glove. Improvement on the word to vec vector characters in itself. Was whenever I give a document, I had lots of words which did not, we call the out of vocabulary word problem. Astex gave us a solution that what if I go with the subword? Presented using subword tokens and it will not become an out of vocabulary. Text, which is the character level based encoding. So can we go to the next one? One is the Elmo embeddings that we have started using. So Elmo stands for embeddings from language model representation. Will understand the likelihood of a word occurring next to each other. So the basic principle, it works on the conditional probability the other word going to be. So Elmo has an advantage of giving that it can give us. So Elmo can also give us the contextual built on the basis of the language model, but the rest of the three embeddings that we spoke earlier are based only on the positional information, which is contextual information. ULMFIT, which is the Universal Language Modeling Fine Model. From the name itself, it is very clear to us. So definitely it has the advantages of what Elmo has. improves the transfer learning, and it helps away to the next slide. So now I would like to what models that came in 2017 and 18, and now every understand the basics behind BERT is the question. But so BERT clarity predictions for the next sequence prediction for question answering and auto summarization and named entity recognition. So now the question so many different applications. Use one model or one encoding technique into able to solve these problem statements, right? Go to the next slide. Transformer. A transformer is something that the BERT is divided into. If I'm going to talk in a sentence, which is going to say this sentence has 4 words. Word in the sentence to a numerical representation, and how it does is on the basis of the both the direction. So what is the difference if it operates in both the directions? So if I know that there is a word sentence on left to right and the other way I come, I will be able to understand between the precedence and the subsequence, what follows and what comes in front of it. If I am able to understand that, use the directions, it will be helpful to us in this regard. Slides. So every model is the data that we use. 800 million words from English book corpus and from the English Wikipedia corpus. You can understand on usually what is the problem in NLP and data to work with. Second problem, and very less clean data to work with, which is the next problem. So the corpus that is available widespread across using the Wikipedia and the books, and they have tried to train it on that. It's able to learn by itself without any the bird model we saw in the first slide of bird. So can we move to the next slide? We know neural network needs a vector to work, and that's why we presentation. The BERT works at 2 levels: language modeling. So it will masking the word. The reason why it had a masked language modeling is, like I said, entire Wikipedia with one has told me that word 1 is category A, word 2 is category B, word 3 for me to understand what is what. We need to mask something or identify the data as such. So what they did is they the predictions the mask language modeling. Utilizing the same model to also identify pattern phrase. The probability that if I say I am not well today. What so I'm going to take a leave today. The other that is also done using but. I have like 500 million words. A word that is not available in my data, which empty. The vector is empty. The vector is sparse or is it is well. So what they have done over here is they have there are two ways in which they in the corpus. Then they put as read, and now there is a tense form of this read. They are doing is they are splitting it into the subword using the language resources you call morphemes that are coming along with the word using the morphological analyzer with this double hash symbol. This represents subwords. So in case I do not have a match with any word, or it is due to the problem of not that I have to represent that word so that my accuracy does not drop. And how do in itself bot is actually going to give us the encodings. It is going to give me the number. It is going to come back and give me numbers. So I use this input, which is the encoding or the embedding into a classifier. Then I have to use this LP on the attention network that it has. So I will go into the next slide. I've put up an illustration taken. So I like to draw is available here. And I have mentioned it as CLS in the diagram. So use the outcome of the BERT model for classification, right? So what am I going to classify into? That is left to us. I can classify this into classes. I can classify even the tokens in it to particular entity. So it advantage bidding into any of the problem statements that I want to. So how would does it? What is the uh, um, to and what is the probability that if there is a probability? So these probabilities are derived and these pro. We'll go to the next slide, sir, please. Clear slides that BERT actually helps us in two things. One is the classification. Second, followed by the other. It predicts the next sequence. So a BERT also does this by just changing. See here, there is a mask. In the previous slide, we did not have a mask on the picture. It means that I'm trying to predict the next sequence, and the embedding of this particular is how each of this layer will propagate this probabilities into the vector representation. compare this vector with what has come from the is going to be so. So let's assume that the word mask that bit and then see how closer the vector representation is to going up here. So then the same manner, the vectors of this particular sentence, scoring of this sentence, I will be able to the next slide, sir. Attention probe is what makes BERT very powerful. Attention probe. These are words which are used interchangeably, so we can go with any one of them. The particular context, which is token of I. Let me assume that it is going to be today. So what along with today? Did alongside each time the attention probe is working. So word vector computations of single word, and in that way it is going to help us to actually use. So that is how the attention vectors are going to tell us how the language model against each other or a particular word occurring together. Attention. Yeah. Can we move to the next slide, sir? And segment information as well. That we saw in word to vec, fast text, and other embedding vector, which is not present in any of the other embeddings that we see in the literature. So that is how word is going to help us to give both NLP layer, which we saw earlier. Can we move to the next slide, sir? Would so. So I would say that I don't have to generate a TF-IDF of my own to do a count vector. Definitely not going to be straightforward because it is just that of information from all the books available, all the Wikipedia sources. It is going to be years and it is going will not support, right? So what the problem here transfer learning is required with respect to that, but not classification techniques. It goes. And it also allows fast tuning because it's going to us with respect to what it had learned earlier with respect to the books and the Wikipedia. So I'm just going to transfer that information into me. Words, which is going to benefit us. Can we go to the next slide? Language model is not new to NLP. Language model is all we have had in a language. Back again, and then transfer learning is making a revolution. Um, can we go to the next?
Thank you so much, madam. Session, ma'am, regarding what to wake and natural language.
Sir,
So thank you for giving such a wonderful industrial experienced information, madam. I hope it is very useful. Thank you so much, ma'am.
Madam, I have one doubt.
Yep.
Madam, could you please explain about question answering and reading comprehension
Okay. Sure.
and
So
about its
let's say that
applications?
what chatbot as chatbots now? So what is question answering? Now you have asked me a question. I'm trying to answer it. Something about questions, and I need to understand the domain. Then neuron works in the brain, and from the information that I am having, I am what question answering is to you first. Then how the algorithm works on it, question answering system